Hello, everyone. We are Pothole Patrol, and we are turning potholes into not holes. Why potholes, you may ask? What's so unique about potholes? Everyone needs to drive to get somewhere, so everyone may encounter potholes when they are going places, and we're all trying to go as many places as we can in our life.
According to the data provided by the city of San Jose, there were more than 1,400 potholes reported through the 311 app in 2022 alone. And according to the AAA Roadside Assistance Report, more than $3 million are paid annually by drivers on pothole related damages. Our solution to the pothole problem? Develop an app that harnesses the power of the community to help report potholes.
Linus Torvald, the creator of Linux, said this during his TED Talk. But I'm looking at the ground, and I want to fix the potholes that's right in front of me before I fall in. So all in all, even Linus Torvald approves the importance of fixing potholes.
And here's our team: Jacob, Tim, Yubo, Patrick, Shomik, Wang, Edward, Emily, and Naveen.
As part of the high level design, we came up with these components: the front end service, back end Go based service, data validation service, which is a ML based service, Postgres DB to persist the data, social reward service, reporting service, and pothole status service. The following workflows are supported: provisioning to upload the photos by the end user, visualize the potholes in San Jose, get potholes reported by a user within a proximity. Due to time constraints of the hackathon, we scoped it down to few MVP components: the front end service, back end Go based service, Postgres DB data validation ML based service. Here is the tech stack: Mapbox for the front end service, Go for the back end service, JavaScript, Node.js, and PyTorch for ML service, and PostgreSDB to persist the data.
So here's a preview of our app, and let's get to the demo.
So we have a 3D map of potholes, and each pothole is represented by one circle, and they vary in size and color based on severity. So if they are larger, they will be more severe. And then as you can see by this legend, the more red they become, the more severe they are. If you'd like to see a bit more closer to see a specific pothole, you can zoom in and check it out. Or if you'd like to see further out, it turns into more of a heat map. More severe potholes are weighted more heavily, and the density of a certain point affects the intensity and color of the heat map. This effect would be much more pronounced with more data points.
Upon landing, the main view is the map of all the reported potholes in our Postgres database. We do have a legend at the bottom right indicating the different color values associated with all of the pothole dots. On the right side, we have a sidebar where users are able to input new potholes. Longitude and latitude data are pulled from the browser's geolocation API, but users can manually edit that too as well. They also have a section for uploading their photos. And for the sake of this demo, we do have machine learning on the back end that will validate whether or not potholes are, or the images that users upload are in fact potholes. And as you can see, for potholes, we get a response that it's a verified pothole image, and for any photos that don't contain potholes, it responds that potholes are not detected. On the back end, these are the two photos we're actually using for this demo. We have one of a regular street with no potholes, as well as an image that does contain a pothole. And this is just a simple post request to the API, and it returns the result from the machine learning algorithm. Additionally, on this page, we have a leaderboard, and this shows the most active users on the website as an incentive for users to get out there and track as many potholes as possible. That's our demo. Thank you.
Even with all these features in our application, we are wanting to expand more. Currently, this application only focuses on identifying potholes, but in future iterations of our application, we do want to expand into reporting structural damage, reporting on hike trails, graffiti cleanups, oil spills, and etc. And with this product, we do want to enable our citizens to participate and make their community a better place and contribute to civic tech. With future additions and refinements, we plan on expanding our application to the global market as well and make a world a better place.
So here's where we get our data from: the City of San Jose and Kaggle. Let's keep our potholes filled. Thank you, everyone. Any questions?